Since ancient times, people have realized how precious and unique our planet is. Nothing has changed today. Just look around and realize how lucky we are to live on a planet that offers everything we need. But are we really sure it's just luck? Can we really attribute to chance all the favorable characteristics that led to the creation and support of life? Well, let me show you all these unlikely characteristics that, when combined, made our existence possible. Now, science has proven that our solar system is part of a galaxy called the Milky Way. But our galaxy is not just any galaxy, like the billions in the universe. Absolutely not. Ours seems to be a so-called quiet galaxy, as defined by astrophysicists. No catastrophic events that disrupt the entire galaxy. The Earth has been lucky, right? However, despite our galaxy being defined as quiet, some areas, such as the galactic center, are neighborhoods to avoid because radiation and other extreme conditions would be disastrous for the development of life. But our Earth, fortunately, has found the calmest corner of the galaxy, one of the most distant arms, about 27,000 light-years from the center, where nothing important and disruptive has happened for ages, or almost avoiding asteroid impacts, excessive supernova explosions, and black holes. By chance, supernovae in our galactic neighborhood are extremely rare events, with millions of years between one explosion and another. The last supernova observed in the Milky Way dates back to 1604, known as Kepler's supernova. Good for the Earth, we can say. Now let's look at Earth's position in the solar system. Fortunately, Earth is positioned in the so-called habitable zone, Goldilocks zone. Neither too close nor too far from the Sun. The Earth orbits at an optimal distance from the Sun, and this positioning allows the existence of liquid water without it evaporating or freezing. A lucky coincidence, you might say, but it's not over yet. Let's consider our Sun. The Earth couldn't have had a better star. It so happens that the Sun is a main sequence star of type G2V, commonly called a yellow dwarf. Its stability and unique characteristics have allowed the development and maintenance of life on Earth for billions of years. Not too big, not too small, with moderate radiation and an astronomically long lifespan. The Sun is a stable and fundamental star for life on Earth. The Sun is in a stable stage of the stellar life cycle, the main sequence, where hydrogen is fused into helium in its core through nuclear fusion. Type G stars have a lifespan of about 10 billion years. The Sun is currently about 4.6 billion years old, which means it is halfway through its existence, ensuring billions more years of energy stability. And fortunately, humans appeared on Earth right in the middle of the Sun's life, when everything is perfect and stable. Almost forgot. Fortunately, at this stage of the Sun, the energy emitted does not vary significantly over short time scales, avoiding extreme temperature fluctuations on Earth. Lucky us, but it's not over yet. With a temperature of about 5,778 K, about 5,500 degrees Celsius, the Sun primarily emits visible light, infrared, and a small amount of ultraviolet, UV, creating favorable conditions for photosynthesis and life. Furthermore, unlike more massive and hotter stars, such as Type O or B stars, the Sun does not emit lethal amounts of ionizing radiation, such as X-rays and gamma rays, which could destroy Earth's atmosphere and sterilize the planet's surface. And what can we say about the stable orbit towards the center of the galaxy? Pure luck. The Sun orbits the galactic center in about 225 to 250 million years, maintaining a regular path without crossing dangerous regions. Now let's talk about Earth. Fortunately, Earth's orbit is almost circular, meaning that the distance from the Sun varies little throughout the year, avoiding extreme temperature fluctuations that could compromise climate stability and life. Earth's orbit follows an elliptical path, but with a low eccentricity of about 0.0167, where 0 represents a perfect circle and 1 a straight line. The Earth is located at an average distance of 149.6 million kilometers, 1 astronomical unit AU, from the Sun, perfect for developing life. The perihelion, which is the closest point to the Sun, is about 147.1 million kilometers, while the aphelion, the farthest point from the Sun, is about 152.1 million kilometers. This variation in distance is only 3.3%, which significantly limits its effects on global temperature. What a luck! Since axial tilt, 23.5 degrees, is the main factor determining the seasons, eccentricity does not have a significant impact. The distribution of solar radiation remains relatively constant throughout the year, favoring a stable climate. But luck doesn't end here. It only gets better. Earth's atmosphere not only provides a perfect composition of gases essential for life, but also acts as a shield against meteors and harmful radiation that would otherwise be fatal. The atmosphere is composed of 78% nitrogen, 21% oxygen, and traces of greenhouse gases, creating an ideal balance for respiration and climate stability. A sigh of relief, isn't it? And if the atmosphere filtering out harmful radiation weren't enough, here comes Earth's strong magnetic field into play, protecting the planet from solar wind and cosmic radiation, preventing atmospheric loss. Now, the mere fact that Earth has been endowed with such a complex process as the magnetic field speaks volumes about how lucky we Earthlings are. Imagine a planet among all the planets in the solar system and beyond, uniquely developing an electromagnetic engine consisting of a solid metallic core swimming in a liquid iron ocean, which, thanks to Earth's rotation, moves around the core, creating a dynamo effect and producing a magnetic field so strong that it sweeps away all solar and cosmic radiation, thus preserving life on Earth. And all this by pure luck. Mind you, at this point, we can also add that our planet has also been equipped with a system of tectonic plates, which further promotes the flourishing of life. Now brace yourselves, because we have arrived at a crucial question in our investigation, namely, what would Earth be like without the presence of the moon? It seems that the moon's role is not just to inspire romantic serenades. Its influence is fundamental to life as we know it. The moon keeps Earth's axial tilt stable at about 23.5 degrees, an essential element for the stability and evolution of life on Earth, and it remains relatively stable thanks to the moon's gravitational pull. Without the moon, the axis could chaotically oscillate between 0 degrees and 85 degrees, causing extreme and unpredictable climate variations. If the axis became nearly vertical 0 degrees, there would be no more seasons. If instead it tilted strongly over 60 degrees, the seasons would be extreme, with months of total darkness and months of continuous daylight, similar to the conditions on Uranus. This means that luck is always on our side. Good to know, but luck continues. Without the moon, days would be much shorter. A terrestrial day could last only 6 to 8 hours, leading to extreme winds and chaotic climate conditions due to rapid rotation. Without the moon, tides would be about 70% weaker, influenced only by the sun. This would have had a negative impact on early life forms, as tides favored the development of life in coastal environments. Without the moon, Earth would be more exposed to asteroid impacts, increasing the risk of catastrophic events like the one that caused the extinction of the dinosaurs. Have you seen the surface of the moon with all those craters created by asteroid impacts? Well, a good portion of those asteroids would have been attracted to Earth if the moon were not acting as a shield. Without the moon, the evolution of life would be different or impossible. With shorter days and weaker tides, life might not have developed in the same way, or might not have developed at all. In conclusion, we can affirm that, fortunately, Earth's ability to sustain life is the result of a unique combination of astronomical, atmospheric, geophysical, and chemical factors. From its position in the habitable zone to the protective action of the magnetosphere and climate regulation systems, every element plays a crucial role in maintaining life as we know it. And all of this is just rolling the dice, having a lot of luck, and believing in chance. Good luck to everyone.